Welcome to Marikamba PU College, Sirsi, Department of Physics.
Next problem, three capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad. They are connected in parallel. What is the total capacitance of the combination? Determine the charge on each capacitor if the combination is connected to a 100 volt supply. Previous case alli series agittu, idu parallel combination agide. Now I am having three capacitors. Now it is the first capacitor. And here is the second capacitor, and here is the third capacitor. Now these capacitors are connected in parallel agide. That means they are connected to a common terminal. They are connected between two common terminals. Okay, now this is 2, 3, 4. Now if we call this as C1 is equal to 2 picofarad and C2, and this one is C3, C1, C2, C3. Now we are having a supply. Now here we are having a supply of how much? It is 100 volt. 100 volt supply ana connect madidre prati capacitor alli ಎಷ್ಟು ಚಾರ್ಜಸ್ ಇರ್ತದೆ ಅಂತ. So first ಇದು equivalent capacitance ಏನು ಅಂತ find out ಮಾಡುವ. Okay, simple ಇದೆ. So solution given, so C1 ಕೊಟ್ಟಿದ್ದಾನೆ, it is equal to 2 picofarad, C2 ಕೊಟ್ಟಿದ್ದಾನೆ 3 picofarad, C3 ಕೊಟ್ಟಿದ್ದಾನೆ, it is 4 picofarad. Pico means it is 10 to the power of minus 12. ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿರೋದೇನು? CP, effective capacitance in parallel combination. Now a potential of 100 volt is applied. 100 volt ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರೆ, now what is the charge on each capacitor? Q1 ಎಷ್ಟು, Q2 ಎಷ್ಟು, Q3 ಎಷ್ಟು ಅನ್ನೋದನ್ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಓಕೆ, now in parallel combination the effective capacitance is sum of the individual capacitances. Now Cp is equal to formula C1 plus C2 plus C3. Simple direct formula ಇದೆ. So that is equal to 2 plus 3 plus 4. Therefore Cp is equal to 9 picofarad. That is equal to 9 into 10 to the power of minus 12 farad effective capacitance. Now a potential of 100 volt is applied. So parallel combination alli ಏನು ಕಂಡೀಷನ್ ನೋಡ್ಕೊಳ್ಳಿ. Parallel combination alli the potential drop across each capacitor remains the same. Charges ಮಾತ್ರ different ಇರ್ತದೆ. Total charge is equal to sum of the charges on individual capacitance ಅಂತ ಹೇಳಿ ಆಗ್ತದೆ. ಇನ್ನು ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ, now what is Q1? Now charge on the first plate Q1 is equal to, it is C1 into V. Voltage is same. Now Q1 is equal to C1 into V. Simple formula ಇದೆ charge. So C1 ಕೊಟ್ಟಿದ್ದಾನೆ 2 into 10 to the power of minus 12 into voltage is 100. So 100 ಅನ್ನು 10 to the power of plus 2 ಅಂತ ಬರ್ಕೊಂಡ್ರೆ 10 raised to minus 12 plus 2 ಅಲ್ಲಿಗೆ 10 to the power of minus 10 ಆಗ್ತದೆ ಕೂಲಂಬ್ ಚಾರ್ಜಸ್. 10 to the power of minus 10 ಕೂಲಂಬ್ ಆಗ್ತದೆ. ಸೊ ಹಾಗೆ second charge on the second capacitor Q2 is equal to, it is C2 into V. Now C2 is 3 into 10 to the power of minus 12 into 100. So ಇಲ್ಲೂ ಅಷ್ಟೇ 100 ಅನ್ನ 10 to the power of plus 2 ಅಂತ ಬರ್ಕೊಂಡ್ರೆ 10 to the power of minus 12 plus 2, it is minus 10 ಆಗ್ತದೆ. So 3 into 10 to the power of minus 10 coulombs. And charge on the third capacitor, so it is C3 into V, that is equal to 4 into 10 to the power of minus 12 into 100. Aligenaito, it is 4 into 10 to the power of minus 10 coulomb. Very simple. Now next problem. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power of minus 3 meter square. And the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. If this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? So very simple is diagram avashyakate beelodilla. So we have a capacitor, parallel plate capacitor. Okay. Now the area is given. Area of each plate is 6 into 10 to the power of minus 3 meter square is given. The distance of separation between the two is given, that is D is equal to 3 millimeter. Millimeter ಕೊಟ್ಟಿದ್ದಾನೆ meter ಗೆ convert ಮಾಡ್ಕೋಬೇಕು. So capacitance C ಅನ್ನು ಕಂಡುಹಿಡಿಯಬೇಕು. Now this capacitor is connected to a supply. Supply ಗೆ ಏನಾದರೂ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ supply ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ, supply of 100 volts. What is the charge is to find out ಮಾಡಬೇಕು. Okay, so solution, given area of each plate is given. Now area is equal to 6 into 10 to the power of minus 3 meter square. The distance of separation D is given, that is 3 millimeter. So ಅದನ್ನ meter ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, that is 3 into 10 to the power of minus 3 meter. Okay, epsilon naught we know the value, constant. Now we have to calculate what is the capacitance. Next ಏನು ಮಾಡಿದಾನೆ, ವೋಲ್ಟೇಜ್ ಅನ್ನ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. How much? It is 100 volts. ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ now what is the charge on each plate, that is charge on the capacitor, that you have to work out. Now the formula, in the case of a parallel plate capacitor, the capacitance is given by C is equal to epsilon naught A divided by D. Simple formula is there. So it is equal to 8.854 into 10 raised to minus 12. Epsilon naught value ಗೊತ್ತುಂಟು, 8.854 into 10 raised to minus 12 ಅಂತ ಹೇಳಿ, into area is given, it is 6 into 10 to the power of minus 3 divided by distance of separation is 3 millimeter, that is 3 into 10 to the power of minus 3. Okay, so ನಿಧಾನ simplify ಮಾಡುವ, 10 raised to minus 3, so 10 raised to minus 3 will cancel ಆಗ್ತದೆ. So if you multiply this one, multiplication ಮಾಡ್ಕೊಂಡ್ರೆ, so it is 1s 2s ಹೋಗ್ತದೆ, so multiply ಮಾಡ್ಕೊಂಡ್ರೆ, so it is 17.71 into, so 10 to the power of minus 12, 17.71 into 10 to the power of minus 12 farad ಬರ್ತದೆ. 10 to minus 12 ಅಂತ ಹೇಳಿದ್ರೆ it is picofarad ಅಂತ ಗೊತ್ತುಂಟು ನಮಗೆ. 17.71 picofarad capacitance. Now I have to calculate what is the charge. Charge ಕಂಡುಹಿಡಿಯೋದು ಹೇಗೆ? So simple formula, capacitance. Now capacitance is equal to Q by V. Capacitance is equal to Q by V. Therefore charge is equal to, it is C into V. C ಇಲ್ಲಿ ಗೊತ್ತಿದೆ, that is 17.71 into 10 raised to minus 12 into V is 100. 100 ಅನ್ನು ನಾವು 10 to the power of plus 2 ಅಂತ ಬರ್ಕೊಂಡ್ರೆ ಅಲ್ಲಿಗೆ minus 12 plus 2 10 ಆಗ್ತದೆ. 17.71 into 10 to the power of minus 10 ಆಗ್ತದೆ. ಅದನ್ನ ನಾನು ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ ಇಟ್ಟರೆ 1.771 into 10 to the power of minus 9 coulomb. 10 to the power of minus 9 coulomb, that is ನ್ಯಾನೋ ಕೂಲಮ್ ಅಂತ ಹೇಳ್ಬೋದು. ಅಷ್ಟು ಚಾರ್ಜಸ್ ಪ್ಲೇಟ್ ಅಲ್ಲಿ ಕಲೆಕ್ಟ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, explain what would happen if in the capacitor of capacitance 1.771 into 10 to the power of minus 11 farad with air, a 3 millimeter thickness mica sheet of dielectric constant 6 were inserted between the plates, while the voltage supply remained connected after the supply was disconnected. So this problem is related to the previous problem. Here given the parallel plate capacitor of distance is of separation between the two plates is 3 mm. Now it is connected to a supply. It is connected to a supply of 100 volts. Okay. So now they are placing a dielectric here. ಏನು ಎರಡು ಪ್ಲೇಟ್ ನಡುವೆ ಸ್ಪೇಸ್ ಇದೆಯಲ್ಲ ಆ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಒಂದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಅನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಈಸ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ಡ್ ವಿತ್ ಸಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೆ. ನೋ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ ತಕ್ಷಣ ನಮಗೆ ಗೊತ್ತಿದೆ ಕೆಪಾಸಿಟೆನ್ಸ್ ಏನಾಗ್ತದೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ ಹೇಳಿ. ದಟ್ ವಿ ವಿಲ್ ವರ್ಕ್ ಔಟ್. Now solution, what are the given things here? Now here given the initial capacitance is given. Now capacitance, if I write C naught, if I write it as C naught is equal to 1.771 into 10 to the power of minus 11 farad. That is initial capacitance is given, and a mica sheet of thickness. Now thickness is equal to distance of separation between the two plates. Eradu equal unto, that is 3 millimeter anta ಹೇಳ್ತಾನೆ. That is 3 into 10 to the power of minus 3 meter ಆಗೋಯ್ತು. Dielectric constant K is equal to 6 ಅಂತ ಕೊಡ್ತಾ ಇದ್ದಾನೆ. 6 ಅಂತ ಕೊಡ್ತಾ ಇದ್ದಾನೆ. ಇದನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ರೆ, ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ರೆ, now what will happen? The capacitance increases ಅಂತ ಗೊತ್ತುಂಟು ನಮಗೆ. C is equal to C naught capacitance with air medium, C capacitance with dielectric medium. Now therefore the capacitance with the dielectric medium is given by, it is K into C naught. Clear unto? So K ಇದೆ, that is 6 ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ ನಾನು. 6 C naught, it is 1.771 into 10 to the power of minus 11 ಇದೆ. Multiplication ಮಾಡ್ಕೊಂಡ್ರೆ I will get 10.6 into 10 to the power of minus 11 ಅಂತ ಬರ್ತದೆ. So farad, or is equal to 106 into 10 to the power of minus 12 farad ಆಯಿತು, or I can write it as 106 picofarad. So ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಬಂದ ತಕ್ಷಣ ಕೆಪಾಸಿಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಯ್ತು, ಈಗ ಜಾಸ್ತಿ ಆಯಿತು ಅಂತ ಹೇಳಿ. ಸೊ ಕೆಪಾಸಿಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂದ ತಕ್ಷಣ ನಾವು, ಸಿನ್ಸ್ ದ ವೋಲ್ಟೇಜ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್, ನಾವು ವಾಟ್ ಈಸ್ ದ ನ್ಯೂ ಚಾರ್ಜ್? ಕೆಪಾಸಿಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂದ ತಕ್ಷಣ ಚಾರ್ಜ್ ಏನಾಗಿರ್ಬೇಕು ಹೇಳಿ ಅಲ್ಲಿ. therefore Q is equal charge, Q is equal to new charge, ಅದನ್ನು Q dash ಅಂತ ಬೇಕಾದ್ರೆ ಕರ್ಕೋಬಹುದು. So Q dash is equal to the capacitance C into V, the voltage applied. Now that is equal to 106 into 10 to the power of minus 12 into, it is 100. So it is equal to 100 ಅನ್ನ 10 to plus 2 ಅಂತ ಬರ್ಕೊಡುವ. So minus 12 plus 2, it is minus 10 ಆಗ್ತದೆ. 106 into 10 to the power of minus 10 ಕೂಲಮ್. ಆರ್ ಇದನ್ನ ಸ್ವಲ್ಪ Q dash is equal to 10.6 into 10 to the power of minus 9 ಕೂಲಮ್, ಆರ್ it is 10.6 ನ್ಯಾನೋ ಕೂಲಮ್ ಆಗ್ತದೆ. ಚಾರ್ಜು ಇಷ್ಟ ಆಗ್ತದೆ ಹೇಳಿ ಯಾವಾಗ ವೋಲ್ಟೇಜು ಕನೆಕ್ಟ್ ಆಗಿ ಇದ್ದಾಗ. Now next case is voltage is disconnected, that is power supply is disconnected. Supply ಅನ್ನು disconnect ಮಾಡಿದ್ರೆ now what will happen? Now part B, the power supply is disconnected. Power supply disconnect ಆಯ್ತು ಅಂದ್ರೆ capacitance ಮಾತ್ರ ಅಷ್ಟೇ ಇರ್ತಾನೆ. That is C, that we have calculated 106 into 10 to the power of minus 12 farad, that is picofarad ಅಂತ ಬರ್ದಿದ್ವಲ್ಲ, ಅವನ್ ಮಾತ್ರ ಸೇಮ್ ಇರ್ತಾನೆ. ಯಾವಾಗ ಈ ವೋಲ್ಟೇಜ್ ಅನ್ನ ತೆಗಿತೀವೋ ನಾವು ವಾಟ್ ಈಸ್ ದ ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ದ ಕೆಪಾಸಿಟರ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅದೇನಾಗ್ತದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಯಾಕೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ? ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇರೋದ್ರಿಂದ ನಾವು ಥಿಯರಿ ಆಫ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ. ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇಟ್ ರಿಡ್ಯೂಸಸ್ ದ ಎಫೆಕ್ಟಿವ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ರಿಡ್ಯೂಸ್ ಆದ ತಕ್ಷಣ ಆಟೋಮೆಟಿಕಲಿ ಏನಾಗ್ತದೆ, ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ ಸಹ ಏನಾಗ್ತದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. Now what is the new potential when the supply is disconnected? ಸಪ್ಲೈನ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ. ಸಪ್ಲೈ ಇದ್ದಿದ್ದಕ್ಕೆ ಅಕ್ರಾಸ್ ದ ಕೆಪಾಸಿಟರ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 100 ವೋಲ್ಟ್ಸ್ ಇತ್ತು. ಈಗ ಸಪ್ಲೈನ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ಅಲ್ಲಿ ಇದ್ದಿದ್ದಂತಹ ವೋಲ್ಟೇಜ್ ಏನಾಗ್ತದೆ, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡಿಕ್ರೀಸ್ಡ್. ವಿ ಬೈ ಕೆ ಅಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಈ ರಿಲೇಷನ್ ಹೇಗ್ ಬರ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ನಮಗೆ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸೊ ಸಿ ಬೈ ಸಿ ನಾಟ್ ಅಂತ ಗೊತ್ತುಂಟು. ಇಟ್ ಈಸ್ ಕೆಪಾಸಿಟೆನ್ಸ್ with the dielectric medium to the capacitance with air, but capacitance inversely proportional to voltage. Therefore ಏನಾಯ್ತು, so it is initial voltage divided by the new voltage. ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ ಇನಿಷಿಯಲ್ ವೋಲ್ಟೇಜ್ ಅನ್ನ ವಿ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೊ ಇಲ್ಲಿ ವಿ ನಾಟ್ ಬೈ ವಿ ಆಗ್ತದೆ, ಅಥವಾ ವಿ ಬೈ ವಿ ಡ್ಯಾಶ್ ಆಯ್ತು. ಆ ಫಾರ್ಮುಲಾ ಹಾಕೊಂಡಿದ್ವಿ. therefore v dash is equal to v by k ಆಗ್ತದೆ. ಸೊ ವಿ ಅಂದ್ರೆ 100 ವೋಲ್ಟ್ ಇದ್ದ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ 6 ಇದೆ, ಅವನೇನ್ ಮಾಡ್ಬಿಡ್ತಾನೆ, ವೋಲ್ಟೇಜ್ ಅನ್ನ ರಿಡ್ಯೂಸ್ ಮಾಡ್ಬಿಡ್ತಾನೆ. 16.67 ವೋಲ್ಟೇಜ್ ಗೆ ರಿಡ್ಯೂಸ್ ಆಗ್ತದೆ. ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಯಾಕಾಗಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನಾವು ಪವರ್ ಸಪ್ಲೈನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ, 100 ವೋಲ್ಟೇ ಮೇಂಟೈನ್ ಆಗಿತ್ತು. ಯಾವಾಗ ಇದನ್ನ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವೋ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಏನ್ ಮಾಡ್ತದೆ, ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ರಿಡ್ಯೂಸ್ ಮಾಡಿ ಪೊಟೆನ್ಶಿಯಲ್ ಅನ್ನು ಡಿಕ್ರೀಸ್ ಮಾಡ್ಬಿಡ್ತಾನೆ. Now the capacitance is this much and voltage is this much. Now what is the new capacity, new charge? The new charge on the system is Q double dash. ಹಿಂದ್ಗಡೆ ನಾವು Q dash ಅಂತ ಬರ್ದಿದ್ವಿ, ಏರ್ ಅಲ್ಲಿ ಇದ್ದದನ್ನ Q ಅಂತ ತಗೊಂಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇಟ್ಟಾಗ Q dash ಅಂತ ಪ್ರೀವಿಯಸ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದೀವಿ. ಸೊ ಈಗ ಬ್ಯಾಟ್ರಿಯನ್ನ ಪವರ್ ಸಪ್ಲೈ ತೆಗೆದ ಮೇಲೆ ಬರೋ ಚಾರ್ಜಸ್ ಅನ್ನ Q ಡಬಲ್ ಡ್ಯಾಶ್ ಅಂತ ಕರೆಯುವ. ನಾವು ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ನಾವು ದಿಸ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಇಂಟು P dash. ನಾವು ಕೆಪಾಸಿಟೆನ್ಸ್ ಸೇಮ್ ಇದೆ, ದಟ್ ಈಸ್ 106 into 10 to the power of minus 12 into this supply 16.67. If I multiply this one and I will get 1.77 into 10 to the power of minus 9 coulomb. That is 1.77 in 7 nano coulomb. ಈ ರೀತಿಯಾಗಿ ಬರ್ತದೆ. Next problem, a 12 picofarad capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? Very simple ಇದೆ. So on capacitor ಇದೆ, I have a capacitor, it is connected to a battery power supply. Simple. Now this is battery of 50 volts. What is the energy stored? Direct capacitance ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ. So capacitance of 12 picofarad. What is the energy stored? Okay, simple ಇದೆ. So solution, given capacitance C is equal to 12 picofarad. Pico means it is 10 to the power of minus 12 farad. Voltage is given, that is 50 volts. Simply we have to calculate what is the energy stored in the capacitor. Simple formula ನಮಗೆ ಗೊತ್ತಿದೆ. The energy stored in the capacitor is half CV square. Half CV square ಅಂತ ಗೊತ್ತುಂಟು. So that is equal to half into capacitance value ಕೊಟ್ಟಿದ್ದಾನೆ. So 12 into 10 to the power of minus 12 into V square, that is 50 square. Now it is equal to half into 12 into 12 to the power of minus 12. 50 square is 2500. Therefore energy is 1.8, 1.5 into 10 raised to minus 8 joules. Now this much amount of energy is stored in the capacitor. Next problem, a 600 picofarad capacitor is connected to is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? Now look here, we have a capacitor 600 picofarad. It is connected to a supply and charged. Supply of 200 volt supply. So it is 600, capacitance of 600 picofarad. Charge ಮಾಡಿದೀವಿ. Now what is the energy stored? Initial ಆಗಿ ಎಷ್ಟು energy stored ಆಗಿದೆ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವ. So solution, given the capacitance C is equal to 600 picofarad, that is 600 into 10 to the power of minus 12 farad, that we have to know. Now voltage is given is equal to 200 volts. What you are going to calculate? You have to calculate energy. For simplicity, we can also calculate charge. Charge avashyakate illa adru saha calculation ಮಾಡಿ ಇಡುವ. Now energy stored in the case of a capacitor is half CV square. Simple formula ಇದೆ, substitution ಮಾಡ್ಕೊಳ್ಳಿ, calculation ಮಾಡ್ತಾ ಹೋಗಿ. 2 into C is, it is 600 into 10 to the power of minus 12 into voltage is 200 whole square. So ನಿಧಾನಕ್ಕೆ simplify ಮಾಡ್ಕೊಳ್ಳುವ. 1 by 2 into 600 into 10 to the power of minus 12 into 200 square ಮಾಡಿದ್ರೆ it is 40,000 ಬರ್ತದೆ. So is equal to 1s are 3s are 4 3s are 12 ಬಂತು. ಪವರ್ಸ್ ಅನ್ನು ಅಡ್ಜಸ್ಟ್ ಮಾಡುವ. ಇಲ್ಲಿ ಬರೀ 4 ತಗೊಂಡಿದ್ದೀನಿ, ಅಲ್ಲಿಗೆ ಇಲ್ಲಿ 10 to the power of plus 4, 10 to the power of minus 8, ಇಲ್ಲಿ 10 to the power of plus 2, 10 to the power of plus 4 plus 2 plus 6 minus 12, that is 10 to the power of minus 6 ಬಂತು. ಅಥವಾ ಎನರ್ಜಿ U is equal to 1.2 into 10 to the power of minus 5 joules. 1.2 into 10 to the power of minus 5 joules. ಇಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಕೆಪಾಸಿಟರ್ ಅಲ್ಲಿ ಸ್ಟೋರ್ಡ್ ಆಗಿದೆ. ಚಾರ್ಜ್ ಕೇಳಿಲ್ಲ ಆದ್ರೂ ಕಂಡುಹಿಡ್ಕೊಳ್ಳುವ. therefore charge Q is equal to, it is C into V. C ಅಂತ ಹೇಳಿದ್ರೆ it is 600 into 10 to the power of minus 12 into V ಅಂತ ಹೇಳಿದ್ರೆ it is 200. Now 6 2s are, it is once again 12 ಆಗ್ತದೆ. So ಪವರ್ ಅನ್ನು ಅಡ್ಜಸ್ಟ್ ಮಾಡಿ 10 is to plus 2, 10 is to plus 2, 10 is to plus 4 ಆಯ್ತು. 10 is to minus 12, minus 12 plus 4, it is 10 to the power of minus 8 ಆಗ್ತದೆ. ಆ ಚಾರ್ಜ್ Q is equal to 1.2 into 10 to the power of minus 7 ಕೂಲಂಬ್. ಇಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಚಾರ್ಜ್ ಈಗ ಸ್ಟೋರ್ ಆಯ್ತು. ಈಗ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು ಅಂತ ಹೇಳಿದ್ರೆ, now this supply is removed. Now the supply is removed, battery is removed, and we are connecting another capacitor, another similar capacitor of same capacitance like this. Now this is charged, this is uncharged. Now what will happen here? Since it is charged, it acts as a battery, source of voltage, and it is going to charge the second capacitor. Second capacitor na charge ಮಾಡ್ಲಿಕ್ಕೆ ಶುರು ಆಗ್ತದೆ. So ಎಲ್ಲಿವರೆಗೂ ಚಾರ್ಜ್ ಮಾಡ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ, since this is 600 and this one is also 600, ಎರಡರ ನಡುವೆ ಚಾರ್ಜ್ ಈಕ್ವಲ್ ಆಗಿ ಶೇರ್ ಆಗೋವರೆಗೂ ಆಗ್ತದೆ. therefore new charge on the system is Q dash is equal to Q by 2 ಆಗ್ತದೆ. ಚಾರ್ಜ್ ಹಾಫ್ ರಿಡ್ಯೂಸ್ ಆಯ್ತು ಅಂದ್ರೆ, ಇನಿಷಿಯಲ್ ಆಗಿ ವೋಲ್ಟೇಜ್ 200 ಇತ್ತು, ಈಗ ಇಲ್ಲ, ಇದು 200 ಇದ್ದಾನೆ, ಇವನ್ ಇಲ್ಲ, ಈಗ ಏನಾಗ್ತದೆ, ವೋಲ್ಟೇಜ್ ಸಹ ಏನಾಗ್ತದೆ, ಡಿವೈಡ್ ಆಗ್ತದೆ. ದಟ್ ಈಸ್ V by 2. Now what is the energy stored? Now the energy stored in the new case is energy stored in the system of two capacitors. Energy stored in the first capacitor plus energy stored in the second capacitors. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, it is 2 into half Q dash V dash. ಸಿಂಪಲ್ ಆಗಿ ಬರೀತೀನಿ, Q dash V dash ಅಂತ ನಾವು ಬರೀತೀವಿ. So that is equal to 2 2 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. Now Q dash is Q by 2 ಆಗ್ತದೆ, Q by 2. V dash ಸಹ ಏನಾಗ್ತದೆ, V by 2 ಆಗ್ತದೆ. Now that is equal to half, ಒಂದು ಹಾಫ್ ಹೊರಗೆ ಇಟ್ಕೊತೀನಿ, ಇನ್ನೊಂದು ಹಾಫ್ ಇಂಟು Q into V, which is nothing but energy in the first case. ಅಂದ್ರೆ ಏನು, ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಕೆಪಾಸಿಟರ್ when the battery is connected, ಆ ಕೇಸ್ ಆಗ್ತದೆ. therefore it is half into, so ಅದರ ವ್ಯಾಲ್ಯೂ ಈಗ ಆಲ್ರೆಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದ್ವಿ, 1.2. it is 1.2 into 10 to the power of minus 5 ಬಂತು. ಇದನ್ನು ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ it is 0.6 into 10 to the power of minus 5. 1.2 divided by 2, that is 0.6 into 10 to the power of minus 5 joules. So ಇಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಆಗಿದೆ. ಬಟ್ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿರೋದೇನು ನೋಡ್ಕೊಳ್ಳಿ, ಹೌ ಮಚ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಎನರ್ಜಿ ಈಸ್ ಲಾಸ್ಟ್ ಇನ್ ದ ಪ್ರೊಸೆಸ್. ಇದು ಸ್ಟೋರ್ಡ್, ಈ ಸಿಸ್ಟಮ್ ಸ್ಟೋರ್ಡ್ ಆಗಿದ್ದು ಹೇಳ್ತು, ಎಷ್ಟು ಲಾಸ್ ಆಯ್ತು, ಸೊ ಅದನ್ನ ಒಂದರಲ್ಲೊಂದು ಮೈನಸ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಸೊ therefore energy lost is equal to U minus U dash. So U ಎಷ್ಟು? It is 1.2 minus 0.6, that is equal to 0.6 into 10 to the power of minus 5 joules. Now this amount of energy is lost. ಹೇಗೆ ಲಾಸ್ ಆಯ್ತದು? While transferring the charges, the energy is lost in the form of heat. Heat ರೂಪದಲ್ಲಿ ಎನರ್ಜಿ ಲಾಸ್ ಆಗಿ ಹೋಗ್ತದೆ ಹೇಳಿ. ಒನ್ ನೋಟ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಎರಡು ಈಕ್ವಲ್ ಕೆಪಾಸಿಟರ್ ಕೊಟ್ರೆ ಈಗ ಮೆಥಡ್ ನಾವು ಮಾಡಿದ್ವಿ. ಒಂದ್ ವೇಳೆ ಏನಾದ್ರು ಅಲ್ಲಿ 600 ಕೊಡೋ ಬದಲಿಗೆ 900 ಅಂತ ಹಿಂಗೇನಾದ್ರು ಕೊಟ್ಟಿದ್ರೆ, ಈಕ್ವಲ್ ಕೊಡದೆ ಬೇರೆ ರೀತಿಯಾದಂತ ಕೆಪಾಸಿಟರ್ ಕೊಟ್ರೆ, ಇನ್ ದಟ್ ಕೇಸ್ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್? ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ವಿ ಹ್ಯಾವ್ ಟು ವರ್ಕ್ಔಟ್ ವಾಟ್ ಈಸ್ ದ ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್. ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಏನು ಅನ್ನೋದನ್ನ ವರ್ಕ್ಔಟ್ ಮಾಡಬೇಕು. ಆ ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ದ ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ between the two capacitors is equal to, it is C1 V1 plus C2 V2 divided by C1 plus C2 ಅಂತ ಹೇಳಿ ನಾವು ಕರಿತೇವೆ. ದಿಸ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ. ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ಕೆ ಫಾರ್ಮುಲಾ. ಇದು ಹೇಗೆ ಬಂತು? ನಾವು capacitance C is equal to Q by V, therefore V is equal to Q by C. ಅಂದ್ರೆ ಅರ್ಥ, C1 V1 it is charge on the first capacitor, C2 V2 charge on the second capacitor. So if you add them, you will get the total charge. C1 plus C2, it is the effective capacitance in parallel combination. ನೋಡಿ, ಈ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ, ಸೊ C1 V1, C1 it is 600 ಅಂತ ಕೊಟ್ಟಿದ್ದ, V1 200 ಅಂತ ಕೊಟ್ಟಿದ್ದ, 600 pico into 10 to minus 12. C2 ಸೆಕೆಂಡ್ ಕೆಪಾಸಿಟರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ, ದಿಸ್ ಇಸ್ 900. ನಾವು ವಾಟ್ ಈಸ್ V2? ಇನಿಷಿಯಲ್ ಆಗಿ ಅದನ್ನ ಏನು ನಾವು ಚಾರ್ಜೇ ಮಾಡಿಲ್ಲ, therefore ಇದು 0. ಈ ಟರ್ಮ್ ಯಾವಾಗ್ಲೂ ಏನಾಗ್ತದೆ? 0 ಆಗ್ತದೆ. ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅದೊಂದು ವರ್ಕೌಟ್ ಮಾಡಬೇಕು. C1 plus C2 ಗೊತ್ತುಂಟು. ಸೊ ಇದನ್ನ ಮಾಡ್ಕೊಂಡು ಕಾಮನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು. ದೆನ್ ವಿ ಹ್ಯಾವ್ ಟು ವರ್ಕ್ಔಟ್ ವಾಟ್ ಈಸ್ ದ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಆರ್ ಎನರ್ಜಿ ಲಾಸ್ಟ್ ಅಂತ ಹೇಳಿ ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. Charges 2 microcoulomb, 4 microcoulomb, 6 microcoulomb are placed at the three corners ABC of a square ABCD of side x meter. Find what charge must be placed at the fourth corner so that the net potential at the center of the square becomes 0. So 4 ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಅಲ್ಲಿ 3 ಚಾರ್ಜ್ ABC ಅಲ್ಲಿ ನಾವು ಪ್ಲೇಸ್ ಮಾಡಿದೀವಿ. 2 ಮೈಕ್ರೋ, 4 ಮೈಕ್ರೋ, 6 ಮೈಕ್ರೋ ಅಂತ ಹೇಳಿ. ಫೋರ್ತ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಯಾವ ಚಾರ್ಜ್ ಅನ್ನ ಇಟ್ರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ O, ದಟ್ ಈಸ್ ಸೆಂಟರ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್, 0 ಆಗ್ತದೆ. ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ವರ್ಕ್ ಔಟ್. Now distance is given, side is given, side is x, AB is x and BC is also x. Then obviously, what about the diagonal? By using Pythagoras theorem, we will get diagonal is equal to root 2 into x. And half of the diagonal, now this length becomes root 2 by 2, that is x by root 2 ಆಗ್ತದೆ. That you have to work out. So diagonal root 2 x ಆಗ್ತದೆ. Now half of the diagonal x by root 2 ಆಗ್ತದೆ. Now all the charges are equidistant from the center O. So given Q1 is given, or QA, if you take QA or Q1, doesn't matter. Q1 is equal to, it is 2 microcoulomb, that is 2 into 10 to the power of minus 6 coulomb. Q2 is given, that is 4 microcoulomb, that is 4 into 10 to the power of minus 6 coulomb. And third charge, Q3, is equal to 6 microcoulomb, that is 6 into 10 to the power of minus 6 coulomb. Now each side is x anta kottidane, and distance from center to the vertices. Now diagonal. Now AC is equal to, now BD is equal to, so by using Pythagoras theorem you can work out, it is equal to root 2 into x ಬರ್ತದೆ. Then half of the diagonal, that is AO, B is equal to BO is equal to CO is equal to DO. ಅದೇನಾಗ್ತದೆ, ಇದರ half ಇರ್ತದೆ, AC by 2 ಆಗ್ತದೆ. Therefore it is x by root 2. So ಇಷ್ಟು ಗೊತ್ತಿದ್ಮೇಲೆ what we are going to calculate, we have to calculate what is Q4, charge at the fourth corner, that is D ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಯಾವ ಚಾರ್ಜ್ ಅನ್ನು ಇಟ್ಟರೆ ಪೊಟೆನ್ಶಿಯಲ್ 0 ಆಗ್ತದೆ ಅಂತ ಹೇಳಿ. And one more thing is given, the potential at O, center O is 0 ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ. ಇದನ್ನ ಬೇಸರಾಗಿ ಇಟ್ಕೊಂಡು we have to work out what is Q4. So very simple ಇದೆ. Now potential at O is equal to 0 ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. We will write the formula. It is 1 divided by 4 pi epsilon naught. It is common. Common ಇರ್ತದೆ ಎಲ್ಲ ಚಾರ್ಜ್ಗೂ. First charge, that is Q1. ಅದರ ಡಿಸ್ಟೆನ್ಸ್ ಏನು AO. Plus second charge Q2. Distance BO. Third charge Q3. Distance CO. Plus fourth charge Q4. Distance DO. That is the formula. Okay, that is the formula. Now therefore V naught is equal to ಯಾವ್ದಾದ್ರು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ ಅದನ್ನೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳುವ. ಇಲ್ಲಿ V naught obviously 0 ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ ನಮಗೆ, 0 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡುವ. Now this is 0, potential is 0. Now look here carefully, ಇಲ್ಲೂ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ದಾನೆ, ಇಲ್ಲೂ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ದಾನೆ, ಇಲ್ಲೂ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ದಾನೆ, ಮೂರು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಆಬ್ವಿಯಸ್ಲಿ ಫೋರ್ತ್ ಚಾರ್ಜ್ ಏನಾಗಿರ್ಬೇಕು, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆಗಿರ್ಲೇಬೇಕು, ಯಾಕೆಂದ್ರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಇಸ್ 0 ಅಂತ ಹೇಳ್ತಾ ಇರೋದ್ರಿಂದ. ನೋಡೋಣ ವರ್ಕೌಟ್ ಮಾಡುವಾಗ. ನಾವು 1 divided by 4 pi epsilon naught is ವ್ಯಾಲ್ಯೂ 9 into 10 to the power of 9 ಗೊತ್ತುಂಟು. Q1 ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ, that is 2 into 10 to the power of minus 6. AO BO CO DO ಗೊತ್ತುಂಟದು, x by root 2 ಅಂತ ಹೇಳಿ, that is x by root 2 plus 4 into 10 to the power of minus 6 divided by x by root 2 plus 6 into 10 to the power of minus 6 divided by x by root 2 plus Q4 that we are going to work out is equal to x by root 2. X by root 2, x by root 2, x by root 2. So now we will further simplify. Here I will do it. Now what are the common things? Take it them out. Common things ಎಲ್ಲ ಹೊರಗಡೆ ತಗೊಂಡ್ಬಿಡುವ. So 0 ಇದೆ ಇಲ್ಲಿ, so 0. So 9 into 10 to the power of 9 divided by, now x by root 2, x by root 2, x by root 2, x by root 2 is common. Take it out. X divided by root 2 here. 2 into 10 to the minus. Now 10 to the minus 3 minus 6 is only common in 3 terms, not in the 4th term. Therefore remain it as it is. That is 2 plus 4 plus 6 into 10 to the power of minus 6 plus Q4. I will write like this. A 3 10 to the minus 6 common idane hagagi. Nodi, here product of two numbers is 0. Therefore the number inside the square bracket is equal to 0. Therefore Q4 plus 2 plus 4 plus 6 into 10 to the power of minus 6 is equal to 0. Or Q4 is equal to, look here, 2 plus 4 6, 6 plus 6 12, plus 12 ಆ ಕಡೆಗೆ ಹೋದ್ರೆ ಏನಾಗ್ತದೆ, minus 12 ಆಗ್ತದೆ. Minus 12 into 10 to the power of minus 6 coulomb. That is the fourth charge. Or the fourth charge, it is a negative of 12 microcoulomb. Minus 12 microcoulomb. ಇದನ್ನ ನಾವು fourth corner D ನಲ್ಲಿ ಇಟ್ರೆ, then the potential at the center becomes 0. ಈ ರೀತಿ ನಾವು ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. Next problem. ABCD is a square of side 2 meter. Point charges of 5 nanocoulomb, 10 nanocoulomb, minus 5 nanocoulomb are placed at the corners ABC respectively. Calculate the work done in transferring a charge of plus 4 nanocoulomb from D point to the center of the square. So ಇಲ್ಲಿ 3 ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದಾರೆ. plus 5, ಇಲ್ಲಿ plus 5 ಕೂಲಮ್ ನ್ಯಾನೋಕೂಲಮ್ ಇರ್ತಾನೆ, ಇಲ್ಲಿ plus 10 ನ್ಯಾನೋಕೂಲಮ್ ಇರ್ತಾನೆ, ಇಲ್ಲಿ minus 5 ನ್ಯಾನೋಕೂಲಮ್ ಇರ್ತಾನೆ. 3 ಚಾರ್ಜ್ ಕೊಟ್ಬಿಟ್ಟು ನಾಲ್ಕನೇದು ನೆಕ್ಸ್ಟ್ ಏನ್ ಕೇಳಿದಾನೆ ಅಂದ್ರೆ, ಫೋರ್ತ್ ಚಾರ್ಜ್ ಆಫ್ plus 4 ನ್ಯಾನೋಕೂಲಮ್ ಅನ್ನ D point in the O point ge displacement madidre, what is the amount of work done antadeli that we have to calculate. Now for that one, we have to calculate first what is the potential at the center due to the three charges, that we call it as VO. VO is the potential at the center due to the first three charges. And next is what is the potential at the point D. D point ಅಲ್ಲಿ potential ಎಷ್ಟು ಅಂತ ಹೇಳಿ find out ಮಾಡಬೇಕು. ಅದನ್ನ VD ಅಂತ ಕರೆಯುವ. ನಾವು difference in potential ಮಾಡಿಕೊಂಡು fourth charge ಇಂದ multiply ಮಾಡಿದ್ರೆ we will get that amount of work is needed or done in moving the charge, fourth charge from D to the center ಅಂತ ಕರಿತೀವಿ. Now side is 2 meter ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ, so therefore AB is 2 meter and BC everything, all the sides are 2 meter. Now according to Pythagoras theorem, the diagonal AC is equal to, obviously it is 2 root 2, and half of the diagonal, that is AO, is equal to 2 root 2 divided by 2, therefore it is simply root 2. It is given in meter, okay, meter alle ide, nothing to worry. Pythagoras theorem prakara adu bandu hoytu heli. So given, now Q1 is given, it is 5 nanocoulomb, it is 5 into 10 to the power of minus 9 coulomb. Now Q2 is given, it is 10 nanocoulomb, that is 10 into 10 to the power of minus 9 coulomb. Q3 is given, look here, it is a negative charge. Q3 is a negative charge, it is minus 5 nanocoulomb, that is minus 5 into 10 to the power of minus 9 coulomb. And we have to first calculate what is the potential at the center due to these three charges, and what is the potential at the fourth corner, that is D. Then we have to work out what is the work done in moving the fourth charge from D to the center O. Okay. Now we will work out one by one. Now let me take the potential at center. The potential at center is given by the formula. This is 1 divided by 4 pi epsilon naught into potential due to the first charge plus potential due to the second charge plus potential due to the third charge. It is algebraic sum. Therefore, I will write Q1 divided by distance is AO plus Q2 divided by distance is BO plus Q3, third charge is Q3 divided by CO. That is the general formula. While solving the problems, you should write the concerned formula. Formula ಬರೀಲಿಲ್ಲ ಹಾಗೆ ಸಾಲ್ವ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಮಾರ್ಕ್ಸ್ ಕಟ್ ಮಾಡ್ರು, ಫಾರ್ಮುಲಾ ಬರೀಲೇಬೇಕು. Okay. Now substituting the values. Now 1 divided by 4 pi epsilon naught, we know its value is 9 into 10 to the power of 9. Straight away. Q1, it is 5. So 5 into 10 to the power of minus 9 divided by AO. So distance from the charge to the center, that is root 2, plus second charge 10 into 10 raised to minus 9 divided by root 2 minus. Now third charge is negative, that's why we are taking minus. It is minus 5 into 10 to the power of minus 9 divided by root 2. Now obviously look here, plus 5 into 10 raised to minus 9 divided by root 2. Minus 5 into 10 to the power of minus 9 divided by root 2, it gets cancels. We only left with the second term. So now simplifying that one. So 10 9s, it is 90 into, so 10 to the power of plus 9 minus 9 get cancels. 90 into, so 1 by root 2. So that is 90 into, what is 1 by root 2? 1 by root 2, you should remember it is 0.707. So root 2 is 1.41, root 2 value. Now 1 upon root 2, you should remember it is 0.707. It comes 0.707. Now if you multiply these two, I will get 63.63 volts. 63.63 volts. Now this is the potential at the center of the square due to the three charges. Now similarly work out what is the potential at the point D due to the same three charges. That we will work out here. Now potential at D, I will write it as Vd. Vd. Okay. Formula is same. 1 upon 4 pi epsilon naught. Now Q1 divided by, now the distance changes. So in the previous case it is from the center. Now it is, distance is AD. Q1 divided by AD plus Q2, charge Q2, second charge divided by, now the distance is diagonal BD plus Q3 divided by the distance is CD. That is the formula. Substitute the values. 9 into 10 to the power of 9. Q1 it is given, it is 5 into 10 to the power of minus 6 minus 9. 5 into 10 to the power of minus 9 divided by AD. What is the value of AD? That is side 2. 2 plus second charge 10 into 10 to the power of minus 9. And once again, the side is here BD, that is the length of the diagonal that we have already calculated. It is 2 root 2. Therefore, it is 2 root 2. Third charge is negative, that's why we are writing minus sign, minus 5 into 10 to the power of minus 9 divided by 2. Once again here, the first term and the third term get cancels. Plus or minus is there, cancel agogtade. Only we left with the second term. It is 9 into 10, that is 90 into 10 to the power of plus 9 minus 9 cancel agtade. 90 divided by 2 root 2. So 90 by root 2 that we have already calculated, it is 63.63. 63.63 divided by 2. 2 in the divide ಮಾಡ್ಕೊಳ್ಳಿ. So ಅಲ್ಲಿಗೆ 2 3 31.815 volts. Therefore potential at D is 31.815 volts. Now we have to work out what is the work done in moving the fourth charge. Therefore, work done in moving the fourth charge is equal to the charge, fourth charge multiplied by the difference of potential. We are moving from the initial point D to the final point O. Therefore, it is VO minus VD. Now, Q4 is 4 nanocoulomb anta kottidane into 10 raised to 9. So, VO, it is 63, we have got 63.63 minus VD 31.815. So that is equal to 4 into 10 to the power of minus 9 into, if you subtract that one, we will get 31.815. Now if you multiply that one, I will get 159.075. If you multiply 159.075 into 10 to the power of minus 9 joules, or work done is equal to 1.59 into 10 to the power of minus 7 joules. Now this much amount of work has to be done in moving a fourth charge of 4 nanocoulomb from the point, from the corner or the vertex D to the center O of the charge system. Now next problem, when two capacitors are connected in series and connected across a 1 kilovolt line, the energy stored in the system is 2 joules. The same capacitors, if connected in parallel across the same line, the energy stored is 9 joules. Find the capacitance of the two capacitors. So, ಎರಡು capacitor ಅನ್ನ first case ಅಲ್ಲಿ series ಅಲ್ಲಿ connect ಮಾಡ್ತಾರೆ as shown in the diagram across a 1 kilovolt supply. Energy stored ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ 2 joules ಅಂತ ಹೇಳಿ. ನೆಕ್ಸ್ಟ್ ಅದೇ ಎರಡು ಕೆಪಾಸಿಟರ್ ನ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ ಅಕ್ರಾಸ್ ದ ಸೇಮ್ ಲೈನ್. ಅವಾಗ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಏನಾಗಿರ್ತದೆ 9 ಜೌಲ್ಸ್ ಬರ್ತಾ ಇದೆ. ಇಫ್ ದಟ್ ಈಸ್ ದ ಕೇಸ್, ದೆನ್ ವಿ ಹ್ಯಾವ್ ಟು ವರ್ಕ್ ಔಟ್ ವಾಟ್ ಈಸ್ C1 and C2 capacitance of the two individual capacitors. Now given solution, given if I take energy stored in a series US ಅಂತ ನಾವು ಕರ್ಕೊಂಡ್ರೆ series combination ಅಲ್ಲಿ ಅಂತ, it is 2 joules. Energy stored in parallel combination, it is equal to 9 joules. So ಈ ರಿಲೇಷನ್ ಇಟ್ಕೊಂಡು ಪವರ್ ಸಪ್ಲೈ ಇಸ್ ಗಿವನ್, ದಟ್ ಇಸ್ V is equal to 1 kilovolt. 1 kilo means it is 1000 volts ಅಂತ ಹೇಳಿ. We have to calculate what is C1 and what is C2. Now we know the general expression for energy stored, that is U is equal to half CV square. C ಬೇಕು, V ಕೊಟ್ಟಿದ್ದಾನೆ, therefore half CV square ಫಾರ್ಮುಲಾವನ್ನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So first case, the two capacitors are connected in series. ಅದನ್ನ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳುವ. So in series combination, that is US is equal to half CS, that is series combination, into V square. Now US, that is energy stored in series combination, 2 joules. 2 is equal to 1 by 2 into series combination of the effective capacitance, CS anta karkoluva ಈಗ ಸದ್ಯ. Okay, into V square. V square is given, that is 1000 square. So 1000 square ಅನ್ನು 10 to the power of plus 3 square ಅಂತ ಬರ್ಕೊಂಡ್ರೆ, 10 to the power of plus 3 square ಅಂತ ಬರ್ಕೊಂಡ್ರೆ ಏನಾಗ್ತದೆ ನೋಡಿ, that is 2 is equal to 1 by 2 into CS into 10 to the power of plus 3 whole square, it is 10 to the power of plus 6 ಆಗ್ತದೆ. Now cross multiplying, I will get CS is equal to 2 2s, that is 4 into 10 to the power of minus 6 ಆಗ್ತದೆ. Or CS is equal to 4 microfarad. So CS ನಮಗೆ ಸಿಗ್ತಾ ಇದೆ 4 microfarad ಅಂತಂದೇಳಿ. Okay. Now CS is the effective capacitance in parallel combination. Now what is the formula for effective capacitance when two capacitors are connected in parallel? That is 1 upon CS is equal to 1 upon C1 plus 1 upon C2. LCM ತಗೊಂಡು simplification ಮಾಡ್ಕೊಂಡ್ರೆ CS is equal to C1 C2 divided by C1 plus C2 ಅಂತ ನಮಗೆ ಬರ್ತದೆ. ಅದರ ವ್ಯಾಲ್ಯೂ ನಮಗೆ 4 microfarad ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ, ಸಿಗ್ತದೆ, ಕೊಟ್ಟಿಲ್ಲ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದೀವಿ 4 microfarad. Now apply the second case when the same two capacitors are connected in parallel. ಇದನ್ನ ಬೇಕಾದ್ರೆ equation 1 ಅಂತಂದೇಳಿ ನಾವು ಕರ್ಕೊಂಡ್ರೆ, now this equation if you call it as 1. Now for the parallel combination ಗೆ UP is equal to half CP, capacitance, effective capacitance in parallel combination, into once again it is V square. UP is given how much? It is 9. 9 is equal to half into, now CP remain as it is, V square once again it is 1000 whole square. So cross multiply ಮಾಡಿ simplification ಮಾಡ್ಕೊಂಡ್ರೆ 9 2s 18 ಬರ್ತದೆ. ಅವಾಗಲೇ ಮಾಡಿದಂತೆ 10 to the power of 3 ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ 10 to the power of plus 6 ಆಗ್ತದೆ. ಅದನ್ನ ಈ ಕಡೆ ಕಳಿಸಿದ್ರೆ it is 10 to the power of minus 6 farad ಆಯ್ತು. Or CP is equal to 18 microfarad. 18 microfarad ಅಂತ ಬಂತು. Now what is the expression for CP in case of parallel combination? Now that CP is nothing but C1 plus C2, that is equal to 18 microfarad. Call this as equation 2. So ಇಲ್ಲಿ ನಮಗೆ ಎರಡು equation ಬರ್ತಾ ಇದೆ. Series combination ಇಂದ ಒಂದು equation ಬಂತು. So CS is equal to C1 C2 divided by C1 plus C2, that is 4 microfarad ಅಂತ ಬಂತು. Parallel combination ಇಂದ CP is equal to C1 plus C2 is equal to 18 microfarad ಅಂತ ಬಂತು. ನಾವು ಈಗ ಫಸ್ಟ್ ಇಕ್ವೇಶನ್ ಸೆಕೆಂಡ್ ಇಕ್ವೇಶನ್ ಅನ್ನು ತಗೊಂಡ್ಬಿಟ್ಟು we are going to simplify. Now substitute equation 2 in equation 1. What we will get? I will write here. Now substituting equation 2 in equation 1, I will get, now CS is equal to, now substituting here, that is C1 C2 divided by C1 plus C2 is in the denominator. I will substitute 18. Now 18, that is equal to, on the right hand side it is 4. Therefore C1 C2 is equal to 72. C1 C2 is equal to 72 ಬರ್ತಾ ಇದೆ. Okay. So now call this as equation. So from 3, relation 3. Now from 2 and 3, we have to work out what is the C1 and what is C2. C1, C2 and work out ಮಾಡಬೇಕು. So ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, we know that C1 minus C2 whole square is equal to C1 plus C2 whole square minus 4C1 C2. ಒಂದು ಜನರಲ್ ಫಾರ್ಮುಲಾ ಉಂಟು. C1 minus C2 whole square is equal to C1 plus C2 whole square minus 4C1 C2 ಅಂತಂದೇಳಿ ಆ ರಿಲೇಷನ್ ತಗೊಂಡ್ರೆ C1 minus C2 whole square is equal to C1 plus C2, that is 18 minus 4 into 72. Now 18 square is 324 minus 288. Now if you subtract, I will get 36. Yes, 36. That is C1 minus C2 whole square. Now what is C1 minus C2? Square root of this one. This is 6. C1 minus C2 is 6. Now from these two relations, addition of two numbers is 18. Subtraction of two numbers is 6. So if we call this as 4, solve 3 and 4. Equation 3 and equation 4 na solve madidre what we will get, just adding those two equations. Now we will get, so if you add second equation and fourth equation, I will get 2C1 is equal to 18 plus 6, it is 24. Therefore C1 is equal to 12 microfarad. Obviously C2 is equal to 6 microfarad. So like this we are going to work out. Next problem, two capacitors of capacitances 1 microfarad and 3 microfarad are charged to 800 volt and 400 volt separately. Find the common potential difference, the charge on each capacitor and the energy dissipated when they are connected in parallel. So ಎರಡು ಕೆಪಾಸಿಟರ್ ಇದೆ, C1 ಮತ್ತೆ C2 ಅಂತ ಹೇಳಿ. ಇದು ಎರಡು ಕೆಪಾಸಿಟರ್ ನ ಬೇರೆ ಬೇರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಗೆ ನಾವು ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಫಸ್ಟ್ ಕೆಪಾಸಿಟರ್ ನ 800 ವೋಲ್ಟ್ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಸೆಕೆಂಡ್ ಕೆಪಾಸಿಟರ್ ನ 400 ವೋಲ್ಟ್ಸ್ ಅಲ್ಲಿ ನಾವು ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೀವಿ ಸೆಪರೇಟ್ ಆಗಿ. ಚಾರ್ಜ್ ಮಾಡಿದಾಗ ವಾಟ್ ಈಸ್ ದ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಫಸ್ಟ್ ಕೆಪಾಸಿಟರ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ ದ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಸೆಕೆಂಡ್ ಕೆಪಾಸಿಟರ್, ದೆನ್ ವಾಟ್ ಈಸ್ ದ ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ದ ಸಿಸ್ಟಮ್ ಅನ್ನ ಫಸ್ಟ್ ವರ್ಕೌಟ್ ಮಾಡಬೇಕು. ಅದಾದ್ಮೇಲೆ ಫಸ್ಟ್ ಕೆಪಾಸಿಟರ್ ಮತ್ತೆ ಸೆಕೆಂಡ್ ಕೆಪಾಸಿಟರ್ ನ ಬ್ಯಾಟರಿ ತೆಗೆದುಬಿಟ್ಟು ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡ್ತಾ ಇದೀವಿ. ನಾವು ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡಿದಾಗ ಇವನ ಎನರ್ಜಿನೇ ಬೇರೆ ಇರ್ತದೆ, ಇವನ ಎನರ್ಜಿನೇ ಬೇರೆ ಇರ್ತದೆ. ಇವನ್ ಪೊಟೆನ್ಶಿಯಲ್ 800 ಉಂಟು, ಇವನ್ ಪೊಟೆನ್ಶಿಯಲ್ 400 ಉಂಟು. Now we have to work out what is the common potential. Common potential ಏನು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು. Then what is the energy stored after connecting parallel. Parallel connection ಮಾಡಿದ್ಮೇಲೆ ಎಷ್ಟು ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಆಯ್ತು ಅಂತ. Then we have to calculate what is the dissipation of energy, that is initial energy minus the final energy, that we have to work out. Now solution, now given C1 is given, first capacitor of 1 microfarad, that is 1 into 10 to the power of minus 6 farad. Second capacitor is given, C2 is equal to 3 microfarad, that is 3 into 10 to the power of minus 6 farad. These two are given. And first capacitor is charged by the power supply or voltage, it is 800 volts. And second capacitor is charged by the voltage, it is 400 volts. Now first we work out what is the energy, initial energy. Now UI is the energy stored in the two capacitors. Now first capacitor energy stored half C1 V1 square plus second capacitor half C2 V2 square. So that is equal to half C1 ಕೊಟ್ಟಿದ್ದಾನೆ, it is 1 into 10 to the power of minus 6. V1 is, that is 800 square plus half into C2 is given, that is 3 into 10 to the power of minus 6 into, it is 400 square. Okay, so ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ half ಆಗೇ ಇರಲಿ, 1 into 10 to the power of minus 6 ಹಾಗೆ ಇರಲಿ into now 800 ಇದೆಯಲ್ಲ, if I write it as 8 into 10 to the power of plus 2, now 8 square it is 64 into 10 to the power of plus 2 whole square is 10 to the power of plus 4. What's the point? Okay, plus now it is 3 by 2 into 10 to the power of minus 6. Here also 4 into 10 to the power of plus 2 whole square. Now 4 square is 16. 10 to the power of plus 2 is 10 to the power of plus 4. Square ಮಾಡಿದ್ರೆ 10 to the power of plus 4 ಬರ್ತದೆ. Now here 1s are 32. Therefore it is 32 into 10 to the power of minus 6 plus 4. It is 10 to the power of minus 2 plus 3 by 1s are here, it is 1s are and it is 8s are. 8 3s are 24. 24 into once again 10 to the power of minus 2. So therefore 10 to the power of minus 2 ಅಂತ ಹೇಳಿದ್ರೆ it is 0.32 plus 0.24. Now if you add this one, I will get 0.56 joules. Now this is the initial amount of energy stored in the two capacitors. C1 ನಲ್ಲಿ separate ಆಗಿ energy store ಆಗ್ತಾನೆ, that is this much 0.32. C2 capacitor energy store ಆಗ್ತಾನೆ, that is 0.24 joules. ಹಾಗಾದ್ರೆ ಎರಡು ಕೆಪಾಸಿಟರ್ ನ ಸೇರ್ಕೊಂಡು ಒಟ್ಟು ಇನಿಷಿಯಲ್ ಆಗಿ ಎಷ್ಟು ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ 0.56 joules ಆಯಿತು. This is the total initial energy. Now we have to work out common potential. Common potential ಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೇವೆ ನಾವು. Now common potential is equal to total charge when those two are connected in parallel. Total charge divided by the total capacitance, effective capacitance in parallel combination, E effective. So ಅದಕ್ಕೊಂದು ಫಾರ್ಮುಲಾ ನಾವು ಹೇಳಿದ್ವಿ, that is C1 V1 plus C2 V2 ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, divided by C1 plus C2, direct formula. C1 V1 plus C2 V2 divided by C1 plus C2 ಮಾಡ್ಬಿಟ್ರೆ that gives the common potential when two capacitors are connected in parallel connection. Now substituting the values, now C1 is 1 into 10 to the power of minus 6, V1 is 800 plus C2 is 3 into 10 to the power of minus 6 into 400 divided by effective capacitance C1 plus C2. So that is 1 plus 3 into 10 to the power of minus 6. Now here 10 to the power of minus 6, 10 to the power of minus 6, 10 to the power of minus 6. Numerator denominator common into that get cancels. Now therefore V is equal to 800 plus 1200 divided by 4. 800 plus 1200, it becomes 2000 divided by 4, that is equal to 500 volts. The common potential becomes 500 volts. Now we have to calculate with this common potential when the two capacitors are connected in parallel. Now what is the final energy of the system? Now I will rub this one and I will calculate here. Therefore UF is equal to half C effective into common potential square, V square ಆಗ್ತದೆ. Substituting that one, that is half 1 plus 3 into 10 to the power of minus 6, V square, it is 500 square. 1 plus 3 is 4, 4 divided by 2 is 2, that is 2 into 10 to the power of minus 6 into 5 square is 25 and 10 to the power of plus 2 square is 10 to the power of plus 4. So 25 into 5 it is 50 into 10 to the power of minus 2, that I will write 0.5 joules. Now this is the initial amount of energy stored when the two capacitors are charged separately, and this is the final energy of the system when those two charged capacitors are connected in parallel. Now energy dissipation, therefore energy dissipated, so initial minus final. Energy dissipated is initial minus the final, so therefore that is 0.56 minus 0.5. Therefore 0.06 amount joules, 0.06 joules of amount of energy is dissipated in the form of heat. Previous one problem alli one capacitor na charge ಮಾಡಿ ಆಮೇಲೆ another capacitor uncharged na connect ಮಾಡಿದ್ವಿ. ಅವಾಗ ಪೊಟೆನ್ಷಿಯಲ್ ಹಾಫ್ ಆಗಿ ಡಿವೈಡ್ ಆಗಿತ್ತು ಅಂತ ಹೇಳಿದ್ವಿ. But here is case is different. Here the two capacitors are charged to different voltages, potentials, and then they are connected in parallel. If that is the case, then you have to work out what is the common potential using this relation. Next problem, when a potential difference of 10 to the power of 3 volts, that is 1000 volts, is applied between A and B, terminals A and B, as shown in the figure. A charge of 0.75 millicoulomb, 0.75 millicoulomb is stored in the system of capacitors. Find the value of C. So here we are having a system of 5 capacitors connected in this network. Now 2 microfarad, 2 microfarad, 2 microfarad, 2 microfarad, another one is C, that we are going to determine. Now here between the terminals A, B, we are applying a potential of 10 to the power of 3 volts. Now what is the value of C? That we have to work out. Now given the voltage applied is 10 to the power of 3 volts, that is 1000 volts. Charge Q is equal to 0.75 millicoulomb, that is equal to 0.75 into 10 to the power of minus 3 coulomb. This amount of charge is stored. Now we have to work out what is the capacitance C. First we will work out what is the effective capacitance, that we will work out, and later onwards we will calculate what is C. We know that the effective capacitance C is equal to Q by V, simple formula. It is the total charge divided by the total voltage applied. Now total charge is given 0.75 10 to the power of minus 3 divided by what is the voltage applied? It is 10 to the power of plus 3. Therefore capacitance C effective is equal to, just simplifying this one, it is 0.75 into 10 to the power of minus 3 minus plus 3 is the numerator hodre, it is minus 6 ಆಗ್ತದೆ. Effective capacitance is 0.75 into 10 to the power of minus 6 or 0.75 microfarad. Farad effective capacitance with one condition. Now from the circuit we will work out what is the effective capacitance. Now look here. Now this capacitor 2 microfarad and this 2 microfarad, they are in series. These two capacitors are in series. So therefore the effective 2 series with 2. Now these two are in series. Therefore effective capacitance of those two capacitors is, so 2 into 2 divided by 2 plus 2, that is 1 microfarad. Similarly, this 2 microfarad capacitor and this 2 microfarad capacitor, if you are getting confusion, if you write it is C1, C2, C3 and C4, then it is better. Now here C3 and C4 are in series. C3, C4 series ಇರೋದ್ರಿಂದ effective 1 micro ಬರ್ತಾನೆ. ಹಾಗೆ C1, C2 series ಅಲ್ಲಿ ಇದೆ. C1 series with C2. ಅದರ effective ಏನಾಗ್ತದೆ? Same ಇದೇ ರೀತಿ, that is 2 into 2 divided by 2 plus 2, that is 1 microfarad. Series combination. Now what happens? Look here carefully. Now this is in series. Now this is in series and parallel with C. ಈಗ ಇವರಿಬ್ರದ್ದು effective ನೋಡ್ಕೊಳ್ಳುವ. C3, C4 ಎರಡು series. That system is in parallel with C. Their effective capacitance of those two, it is C plus their effective is 1 microfarad. 1 C plus 1 microfarad. So ಇವನ್ನ ಸೀರೀಸ್ ಮಾಡಿದಾಗ ಸಿಂಗಲ್ ಕೆಪಾಸಿಟರ್ ಬಂತು. ಹೀಗೆ ಬರೀತೀನಿ ನಾನು ಸರ್ಕ್ಯೂಟ್ನ. ಇವನ್ ಎರಡು ಕೆಪಾಸಿಟರ್ C1 C2. ಸಿ ಅನ್ನ ಹಿಂಗ್ ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಐ ಆಮ್ ರೈಟಿಂಗ್ ಇನ್ ದಿಸ್ ಫ್ಯಾಷನ್ ಸಿ. ಇಲ್ಲಿ ಇವರಿದ್ದಾರೆ. I can write circuit like this. You know, the same circuit can be written in this fashion. Now these two are in series. Now he is parallel with the C. ಇವರಿಬ್ರು ಎಫೆಕ್ಟಿವ್ ಏನಾಯ್ತು, ಸೀರೀಸ್ ಇದ್ದಾಗ 1 ಮೈಕ್ರೋಫ್ಯಾರಡ್ ಬಂದ ಅವ್ರದ್ದು ಎಫೆಕ್ಟಿವ್, ಅವನು ಇವನಿಗೆ ಪ್ಯಾರಲಲ್ ಇದ್ದಾನೆ, therefore C plus 1 ಮೈಕ್ರೋಫ್ಯಾರಡ್ ಆಗ್ತಾನೆ. C plus 1 ಮೈಕ್ರೋಫ್ಯಾರಡ್. ಈಗ ಏನಾಯ್ತು ನೋಡಿ, ಇವನಿನ್ ತೆಗೆದ್ಬಿಟ್ಟು ಸಿಂಗಲ್ ಕೆಪಾಸಿಟರ್ ಇಡುವ, ಅವನ ಕೆಪಾಸಿಟೆನ್ಸ್ C plus 1 ಇದ್ರೆ ನಾವು ದ ಸೇಮ್ ಸರ್ಕ್ಯೂಟ್ ರಿಡ್ಯೂಸಸ್ ಟು ಸಿಂಪಲ್ ಆಗಿ ರಿಡ್ಯೂಸ್ ಆಯ್ತು ನೋಡಿ. ಇವರಿಬ್ರು ತೆಗೆದು ಎಫೆಕ್ಟಿವ್ C plus 1 ಅನ್ನು ಹಾಕ್ತೀನಿ ನಾನು ಇಲ್ಲಿ. C plus 1 ಇಲ್ಲಿ ಇವನು 2, ಇವನು 2. ಓಕೆ, therefore the effective final effective capacitance C effective is equal to 1 upon, since they are in series, now 1 upon C effective is equal to 1 by 2 plus 1 by 2 plus 1 upon C plus 1. 1 by 2 plus 1 by 2 is, it is 1. 1 ಬರ್ತದೆ ಗೊತ್ತುಂಟು 1 ಅದು. For 1 upon C effective is equal to 1 plus 1 by C plus 1. Now ಇದನ್ನ ನಿಧಾನಕ್ಕೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡ್ರೆ it is C plus 2 divided by C plus 1 ಆಯ್ತು. ಇದು ಕೊಟ್ಟಿದ್ದಾನೆ 1 upon C effective. C effective ವರ್ಕೌಟ್ ಮಾಡಿದೀವಿ. C effective 0.75. 1 upon 0.75. 0.75 ಅಂತ ಹೇಳಿದ್ರೆ it is 3 by 4, therefore it becomes 4 by 3. ಏನಾಗ್ತಾನೆ, so 1 upon 3 by 4 that is equal to C plus 2 divided by C plus 1. Therefore 4 by 3 is equal to C plus 2 divided by C plus 1. Solve for C here. 4C plus 4 is equal to 3C plus 6. Therefore C is equal to 2 ಮೈಕ್ರೋಫ್ಯಾರಡ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ 0.75 ಅಂತ ಬರ್ತಾನೆ, 0.75 ಅನ್ನ ನಾವು 3 by 4 ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಈಸಿ ಆಗಲಿ ಅಂತ ಹೇಳಿ 3 by 4 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ ಅಷ್ಟೇ. And simplifying this one, you will get a 2 microfarad capacitor is to be connected. The value of C is 2 microfarad.